Great question. So it turns out that there are functions that do not have elementary antiderivatives. So there are integrals that they have solutions, but we cannot express the solution in terms of elementary functions. So let me first explain what's an elementary function. So an elementary function is a polynomial or a rational function, a quotient of polynomials, or an exponential, a logarithm, a trigonometric function, or addition, multiplication, composition of such functions, or root extraction of one of those. So here's an example of an elementary function. We have roots, we have logs, exponentials, trigonometric functions, compositions of such things. So this is elementary. And the issue is that there are integrals, such as this one, such that the solution cannot be expressed as any elementary function. And the question is, how do you prove that? How do you prove that there is no elementary function that is an antiderivative for this function? So it was in the 1830s that Liouville proved the first results of this type, proving that there are integrals that do not have an elementary solution. So for example, here he proved that if f and g are rational functions, then this integral has an elementary solution if and only if this differential equation has a solution with r being a rational function. So it gives you a criterion to show things that are elementary and things that are not elementary. For the function we wanted to consider, that will be elementary if and only if there is a rational function that satisfies this differential equation. And one can show that that is impossible. There is no such solution. In general, the general theorems of Liouville were proved using what we now call differential Galois theory, which I'm not going to get into it in this TikTok. But if you want to learn more about this and about the proofs of Liouville's theorems, then go check Impossibility Theorems for Elementary Integration by Brian Conrad, which I think is a very nice introduction to this subject.